This video will examine Tesla's latest master plan in greater detail, which is we will examine the three main pillars of the strategy, which will pave the road for a world free of fossil fuels: electric cars, heat pumps, solar energy production, and battery storage. In particular, we'll be discussing heat pumps and their operation, as well as analyzing Tesla's creative use of heat pumps in their electric cars. So, buckle up, because we're about to witness the start of a new era in sustainable energy. To begin, make sure you subscribe to our channel and gave this video a thumbs up. Then sit back, unwind, and let's get started. Tesla has always been dedicated to accelerating the global transition to sustainable energy. And in part 3 of its master plan, the company has identified 3 important pillars to accomplish this goal. These pillars are electric vehicles, heat pumps, solar energy production, and battery storage. Elon Musk and his Tesla team claim that the widespread use of heat pumps in homes and businesses, the new master plan is essentially a roadmap to a sustainable future where the world has completely eliminated its reliance on fossil fuels. To achieve this goal, we must stop burning things for energy, including coal and gasoline. And things will have an impact on reducing fossil fuel consumption just as much as electric vehicles. First diesel, then natural gas. In order to fully switch to sustainable energy, we must swap out gas heaters and stoves for cleaner alternatives like electric heat pumps have a big impact. According to the master plan, switching to electric vehicles will cut global fossil fuel consumption by 21%, while switching to heat pumps entirely will cut it by 22%. Additionally, the cost of investment for full switch to heat pumps is only $873, whereas replacing all vehicles with battery-powered electric versions would cost $7 billion. So what is a heat pump, and how does it work? Although it may seem contradictory, a heat pump is a high-efficiency electric heater that transfers heat from outside your home to inside. It does not produce heat. Instead, it collects and transfers heat from the outside. According to experts, the basic principle of hot and cold is relative, and the greater the energy difference, the greater the sensation of hot or cold. The temperature difference between a person's body and the pool water is higher than usual, but as they spend more time in the pool, the cold station dissipates because the heat energy in their body equals the energy in the water. The second law of thermodynamics supports this idea, which states that hot always moves toward cold, meaning that energy will always flow from higher densities to lower densities. Heat pumps employ this natural law to their advantage by transferring energy from the exterior of the house to the inside. Heat pumps actually pump refrigerant, which is a liquid with a very low boiling point that will evaporate at room temperature. In the past, refrigerants were bad for the environment because they caused holes in the ozone layer. But these days, refrigerants like Ron 134a don't do the same harm. The heat pump's moving component, the compressor, compresses the vaporized refrigerant to raise the temperature and the energy density. After that, the hot gas is pushed inside the house using a wall mount blower system in which a fan circulates room temperature air over a hot gas coil. The refrigerant cools down to perform its next function, which requires it to get even colder. To do this, it passes through an expansion valve that quickly lowers the pressure and lowers the temperature back down to where the chemical is liquid again, typically around negative 20 degrees Fahrenheit or negative 30 degrees Celsius. The heat energy from the compressed gas follows the airflow into the room as the heat energy escapes into the house. After that, the extremely cold liquid is sent to the heat pump's external coil, where it absorbs energy from the surrounding air. The refrigerant then absorbs energy from the outside air, rises in temperature, boils into a gas, is compressed even further, and is pumped into the home. In 2020, Tesla unveiled the Model Y, its first heat pump after using electric resistive Tesla has adopted a different strategy with their Model Y, which uses a highly efficient heat pump to keep the cabin warm in cold weather. The heat pump uses a refrigerant that rapidly compresses and decompresses, increasing and decreasing in temperature in the process. The heat energy from this process is then transferred into the cabin via a wall mount blower system. Resistive heating is a low efficiency heating method that sends energy from the battery into the coil of metal. Traditional resistive heating methods used by most electric cars consume a lot of energy and reduce vehicle range. Compared to the Ford Mustang Mach-E's heat pump system, which has 35 parts and 18.4 meters of hose, our system is much simpler and more efficient because it only requires 10 distinct parts and 6.3 meters of hose. In order to replicate the idea of a circuit board with all required parts and connectors integrated into a single unit, Tesla's engineers designed the heat pump, which compacts the entire thermal system into a single unit about the size of a basketball. The idea that electric vehicles don't function in cold locations has been dispelled thanks to this creative method of heating the cabin. It's hardly surprising that other manufacturers are finding it difficult to compete with Tesla's dedication to innovation and efficiency, as demonstrated by the Model Y's heat pump. Tesla is changing the way we think about heating and cooling electric vehicles with its innovative and effective heat pump. Tesla's heat pump design overcomes this problem and is noticeably more efficient than competing models, making electric cars more feasible in cold climates. The resistance of the metal used in the system concentrates energy, raising the temperature, and a fan blows cool air over the metal coil, directing the hot air towards the car's cabin and reducing vehicle range. To develop a small and effective thermal system the size of a basketball, Tesla's engineers were motivated by the construction of a circuit board known as the octal valve. This device enables the heat pump to operate in reverse, doing away with the need for separate heating and cooling units. They have since created a completely automated production method for their heat pump that can make one of their super manifolds every 7 seconds and has a 99.995 success rate at high quality. Tesla has alluded to the creation of a home HVAC system that would transform the way we heat and cool our houses by using the same heat pump design as its electric cars. The Tesla heat pump system is a groundbreaking innovation that has the potential to change how we heat and cool our cars and homes. The company's unique design and fully automated manufacturing system are setting a new standard in the industry. With Tesla's commitment to innovation and environmental responsibility, they could be the company to lead the way in the switch to heat pumps. Elon Musk has stated that the current heat pump design can be scaled up to heat a house or even a business, and if Tesla can deliver the same level of efficiency and manufacturing scale at larger sizes, it could alter the HVAC industry. We appreciate you viewing our video on Tesla's new master plan for a sustainable future. As we've seen, the adoption of heat pumps for home and industrial heating is just as impactful as electric vehicles in reducing fossil fuel consumption. By implementing heat pumps for home and industrial heating, we can eliminate our reliance on natural gas and achieve a sustainable future with more than enough energy to power our global civilization. It's hardly surprising that other manufacturers are finding it difficult to match Tesla's groundbreaking ideas, given its innovative approach to heating and cooling, which uses an incredibly efficient heat pump. Please be sure to click the like and subscribe buttons to show your support for our dedication to a sustainable future and to work together to create a cleaner, greener world. We appreciate your time, and we'll see you in the upcoming video.